Alright, so here's our next section. This is all about special right triangles. So let's jump into this warm-up, get this video done. Number 1, find x. X is one of the legs, since it does form the right angle. So that means it's either A or B in Pythagorean theorem. So you're going to do x squared plus our other leg squared, which is the 7, equal to the only thing left, 12. So now, we need to square everything. X stays squared like it is. 7 squared is 49, and 12 squared is 144. If we subtract 49 from both sides, cancels on the left. We're left with x squared is equal to 144 minus 49 comes out to be 95. And then we square root both sides. Cancels the square on the left. And we're left with x equal to square root of 95. Comes out to be, it's not quite 100, right? Because 100 square rooted is 10. So it's going to be almost 10, but not quite. That's 9.747. The second one, we need to determine whether the set of numbers can be the measures of the sides of a triangle. And 16 plus 30 is 46, which is greater than 33. So it can be the sides of a triangle. So now we need to classify it. So we need to take our largest side, the 33, and square it. And then the other two sides we're going to square and add together. So 16 squared plus 30 squared. 33 squared comes out to be 1089, 1089. 16 squared is 256, and 30 squared is just 900. Now we need to add on the right side. Got 1089 on the left. 256 plus 900 comes out to be 1156. And 1089 is less than 1156, which means this is an acute triangle. So, the first thing we're going to look at today, so there are two types of special right triangles. One is the 45-45-90 triangle. So the 45-45-90 triangle theorem says in a 45 degree, 90 degree, so you just call it 45-45-90 triangle, the legs L are congruent and the length of the hypotenuse H is square root of 2 times the length of a leg. So in this triangle, L is equal to L and H is equal to L times the square root of 2, or L square root 2. So let's look at an example with this. So we need to find x, that's the hypotenuse, and we only have one leg of this triangle, but it is a 45-45-90 triangle since we know one angle is 45 and the other one's a right angle, which means that the third angle has to be 45. They all add up to be 180. So that means that we have our special right triangle, and we can use that theorem we just learned. So all we have to do is take the 9, that is our L, and remember from the last thing, H is equal to L square root 2. So we just plug in, H is X, by the way, in this case. That means that X is equal to L, which is 9, square root 2. And if we want to, we can just leave it exactly like that, and that's what we're going to do. We're not going to actually get that into a decimal. Most of the time with these, you just leave it as the square root. That kind of includes the ones we've been doing, by the way, but a lot of times you can simplify things too, so we would simplify them down. So our next one here, again, we're finding x, which is the hypotenuse, but now our sides are 6 square root 2. Our legs are. So let's write everything out again, just like we did before. L is 6 square root 2. H is equal to x. And we know that H is equal to L square root 2. Now, since we already have the square root 2 in here, it's going to make it to where we have to multiply those together. So h is equal to 6 square root 2 times square root 2. When you multiply a square root of something that has the same number inside, you can just get rid of the square root. So you're going to multiply the things together that are in the square root, basically. So 6 square root of 2 times 2 is what we're having here. So h is equal to 6 times the square root of 4. And the square root of 4 is 2, so this is just equal to 6 times 2. So h is 12. Okay, here's a different one. Now we're looking for our legs, but we have our hypotenuse. So let's set up exactly what we've been doing. So we know that L is equal to A, H is equal to 8, H is also equal to L square root 2. So that means that H is equal to A square root 2. So we need to divide by the square root of 2. Cancels on the right. Now, I don't know if you guys have ever been taught this before, but you cannot leave a square root on the bottom. No radicals on the bottom of a number. So what we need to do is get rid of it, and the way to do that is to multiply that number by square root 2 over square root 2. So we're going to multiply this by square root of 2 over square root of 2. So what that does is, just like on the previous problem, we're going to multiply what's inside of the square roots together. So then we end up with 8 square root 2 on the top over square root of 2 times 2, which is equal to 8 square root 2 over the square root of 4. We know that the square root of 4 is 2, so it's 8 square root 2 over 2. So we can now divide. 8 divided by 2 is 4, so A comes out to be 4 square root 2. So this is kind of backwards of what we just did on the last problem, right? Our legs were 6 square root of 2 before, and we end up with a whole number for our hypotenuse. Now we have our whole number as our hypotenuse. We're working backwards, and we end up with a square root 2 with our number. Now, if 8 was not like an odd number, like 9, we would have ended up with a fraction here. It would have been really ugly looking, where it would have been like 9 square root 2 over 2. We would have left it like that. But since we did have an even number as our hypotenuse, we can simplify it and make it easier. Our second type of special right triangle is a 30, 60, 90 right triangle. So in this case, it's a little bit more complicated, where our hypotenuse is equal to 2 times the shortest length. The S is the length that is across from our 30-degree angle. It's our smallest side, shorter S, that's why it's S. So you multiply that length by 2 to get your hypotenuse, and then the other leg, L, the longer leg, is equal to S, shorter leg, times the square root of 3 this time. So the way you could keep that in mind is that you have a 30, 60, 90 triangle. 30, 60, 90 are all divisible by 3. So the square root for this one is going to be 3. Okay? The hypotenuse is always double the length of the shortest side on a 30, 60, 90 triangle. So let's take a look at some examples with this. So here's our first one. We have our shortest side. It's kind of ugly. It's 4 square root 3 over 3. We need to find both our other two sides, the hypotenuse and the other leg. So we use the equations we just looked at. So we know that H is equal to 2S. We know that L is equal to S square root of 3. In this case, we have our S, which is equal to 4 square root 3 over 3. So we're just going to plug that into these two equations we just wrote down and actually figure out what they are. So X in this case is our L. L is X. Let's replace that. Switch it around. And then H is Y. Okay? So we plug everything in that we just wrote down. So for h equal to 2s, that becomes y is equal to 2 times 4 square root 3 over 3. So we can multiply the 2 and the 4 together. So y is equal to 8 square root 3 over 3. And there is absolutely nothing else we can do about that. That is our answer. That's what y is. X, which is L, is equal to S, so 4 square root 3 over 3 times square root of 3. So now, just like we did before, we can multiply what's inside of the square root together. So we get x is equal to 4 square root of 3 times 3 over 3, which is 4 square root 9 over 3. We know that the square root of 9 is 3, so this is 4 times 3 over 3. And before I multiply 4 times 3, notice that we have a 3 on the bottom as well. They'll cancel out. So x is 4. So nice, pretty long leg, really ugly looking short and hypotenuse. So here's a real world example. We have a quilt that has a side length of 3 inches. Sorry about that. I had an announcement going on in the school, and I paused the video to cut it off so you didn't hear what the announcement was. So quilting. A quilt has the design shown in the figure, in which a square is divided into 8 isosceles right triangles. Isosceles means we have 2 legs that are the same. Right triangles means that we have a 45, 45, 90 triangle all over this. If the leg of one side of the square is 3 inches, what are the dimensions of each triangle? So first off, the legs are going to be easy to find, right? So if we have a square, we know that these 2 pieces are cut in half to make this isosceles right triangle. These are all the same. All these lengths that I'm marking here are the same. Also, the hypotenuses should all be the same. Okay? So really, since that's being split in half, we know that the short, or the, not the short side, but the legs of these triangles are half of the 3. So L is equal to 3 over 2. So L is equal to 1.5 inches. So we got our legs, so now we need to find our hypotenuse. We know that h is equal to L square root 2. So h is equal to 1.5 times square root of 2. And the unit's inches. We'll just leave it as a square root. So there we go. That is our dimensions for our triangles. And with that, you got our exit ticket. Get it done, and we'll see you next time.